Hello, everybody. Here we are, lesson 1.3, measuring line segments. There's a few notes I want us to start with before we get into the lesson. There's a little bit of review, and then I'm going to show you kind of the main thing that we're doing today. I wonder why that doesn't have lines. It's not ideal, but we'll figure it out. So let's go for it. Notes right here, the things that I want us to remember. I'm going to talk a little bit about the relationship between the side length and the area. So I'm going to write it out in words first. So side length squared. Just going to write it out using words equals area. Okay. I'm going to show like this side length. And I'll put it in brackets and show squared as a symbol equals area. And so I'm also going to write it SL. You might see me write it like that equals A. Okay. Side length squared equals area. And then another part of this is the kind of reverse relationship that the square root, maybe I'll do another color. Square root of the area equals side length. Oops. Length. And I'll show that with symbols as well. So the square root of the area equals the side length, like that. Okay, so that's all the stuff I would like you to write there. I'll give you a second to write it down. I was going to put another thing here. I might have run out of space for myself. Maybe I could make this a little bit smaller. The other part that I was going to show you, and maybe we have just some room right here, is well, I wanted to remind you of the formula for area of a triangle. So area of a triangle. So I can sometimes write this as A with a triangle symbol. And that's going to equal, I'll show you, base times height divided by 2. So if I had a nice triangle like this, say it's 4 tall and 2 wide, we would have the base, so 2 times the height, 4 divided by 2. 2 times 4 is 8. So 8 divided by 2 equals 4. Essentially what we're doing when we're doing the area of a triangle, we're kind of finding the area as if it was a square and then slicing it in 2. So that's what we're doing. We're kind of finding it as if it was a whole square, and then dividing by 2 is kind of slicing it in half. So those are the kind of 2 ideas we're going to try to hold for this next section for measuring line segments. The relationship between the side length and the area. Side length squared equals the area, and the square root of the area equals the side length. And we're going to try to remember this formula for the area or the space that a triangle takes up, which is the bottom part times the height divided by 2. The cool part about multiplication is the order doesn't matter. You could have considered that the base and that the height, wouldn't change it. But that's what we use, base times height divided by 2. So let's go. This part is just maybe a bit of review. So 5 squared, remember 5 times 5, that's what that squared means. It means times itself, 2 of them equals 25. This square root is asking us what times itself equals 196. So let's do my calculator. 196 square root button is 14. This means 8 times 8, 8 times itself, 2 8s, that's going to be 64. The next one, this is asking what times itself gives us 225. So 225 square root button is 15. Okay, this one is saying 1 times 1, that just equals 1. This is saying what times itself gives us 49. I know that to be 7. This one again, 9 squared, that's 9 times 9, which I know to be 81. And this one, the square root of 10,000, what times itself gives us 10,000? Let's use our calculator. 10,000 square root is 100. Okay, kind of a bit of a review of the last 1.1 and 1.2. Let's do the next part. This part we have to remember the two relationships that I just outlined at the beginning of this video. So the area A of a square is given how much space it takes up. Find its side length. Okay, which side lengths are whole numbers? Okay, so this is asking us which ones are perfect squares. Okay, so here, look, I'll draw it for you. Don't have to draw it each time, but we have the area equals 9. It's covering 9 centimeters squared. So what is the side length? If you'll recall, the square root of the area equals the side length. So we have to do the square root of 9, which equals 3. So 3 times 3 is what equals 9. The next, we have the area is 56. We're looking for the side length. So we have to take the square root of the area of 56. This doesn't really, stand out to me as one of our perfect squares. So I think it's going to be a decimal. Let's do square root button. Yeah, 7.48 equals 7.48. Next, we have the area is 81. Remember, if we take the square root of the area, we'll find the side length. What times itself equals 81? I know that to be 9. Oh, and this is my bad. We should be using the units that they've given us. So this is in centimeters. So our side length is 9 centimeters. This one was in meters. So this is 7.48 meters. This one was in centimeters, so our side length is 3 centimeters. Okay. Let's go on. We're looking for the area, so we're looking for the square root of 16. So what times itself gives us 16? I know that to be 4, and we're working in meters, so it's 4 meters. Next, we have the square root of 42. This one, it doesn't stick out as one of our perfect squares, so I think it's going to be a decimal again. Let's find out. 42 square root. Okay, 6.48. 6.48, and it's centimeters. Last one, we're looking for the square root of 72. This 72 doesn't stand out as one of our perfect squares, so let's try it. 72 square root. I'm going to round it up, 8.49. It equals 8.49 meters. And which ones are, which side lengths are whole numbers? Are perfect squares. So 9, 81, and 16. Okay. So we did that a little bit. We didn't get as many decimals last time, so that might be new for us. And here's the part of the new learning from today is finding an area of a square that's on its side. If this were, just drawn nicely like this, it's a bit easier. You can just count 1, 2, 3, 4. But if it's on its side, we can't really rely on that method. So there's different ways that we have to do things. So the way that we're going to do this is we're going to draw a square outside of it that touches all of the corner, the vertices, and we're going to calculate the big square and then minus these triangles. That's why I was talking earlier about the area of a triangle, because we need to find out these triangles and then minus them from the big one. This one's kind of hard to see what's going on with our squares here. I'll do my best to. So that looks like that's 1, 2, 3 squares there, and 1, 2, 3, 4 squares there. Okay, I think we can do that, even though it's kind of misprinted. I'll try to print it better for you folks. And that means we would cover 1, 2, 3, and this would be another 4 right there. That would be 3. That would be 4. That would be 3. That would be 3. That would be 4. Okay, I think we can do this. So the big square is going to be 3 plus 4 long. So 7 by 7 is our big square here. Now remember, 7 times 7 is 49. So the big square covers 47 squares. So this kind of like whole thing here, if we did that, the whole big square covers 49 squares. But now we need to minus out these parts right here. And then we'll get our inner square. So the way we can do that, remember, the area of a triangle equals base times height divided by 2. So we have a triangle. The base, we can think about it as 3 times 4 divided by 2. So our triangle right here, it's got a side length of 3 and 4. We're going to divide that by 2. So 3 times 4 is 12 divided by 2. 12 divided by 2 is 6. Okay, wonderful. So we found the area of this triangle right here is 6. But there's 1, 2, 3, 4 of those triangles. So we have to go 6 times 4 equals 24. So now we have our big square, 49, minus our 4 triangles, 24, equals, let's do that in my calculator, 49 subtract 24 equals, okay, 25. I guess we could call it like units squared. That's the area of our inner square, 25. Okay, so good number of steps, but there we go. We get there somehow. I'll leave that for a second. Maybe I'll pause it because I need to, I think, erase some of this to work on our next question. Maybe I'll do the next one, then I'll let you do C and I'll pause, and then we can do the next part together. Okay, so I'm going to erase a bit now so I have room. So the next part, we need to find, make a big square that connects the corners. And then let's calculate the area of the big square and minus our triangle. So the big square is going to be 1, 2, 3, 4, 5, 6, 7, 8. So 8 by 8. So our big square is 64. Now we need to minus these small squares. And that would be, okay, it looks like it's 2 there, and 1, 2, 3, 4, 5, 6 there. So it's going to be 2 times 6 divided by 2. This is our triangle, area of a triangle. 2 times 6 is 12. 12 divided by 2 equals 6. Okay, just like this one, but different shape. So now we got to find, there's 4 of them. Remember, there's 4 of our small triangles. So 6 times 4 equals 24. So now let's take our big square, let's minus our 4 triangles, and we should get the area of our inner square. So 64 minus 24 equals 40. 40 units squared. Okay, Let's see this one. Okay, I'm going to do part 2 in case you're watching this at home and you need to know how to do this. So you need to copy the line segment onto a grid paper and draw a square from the line. And the best way that I can think about do this or teach you how to do this is to, from one dot to the other, do kind of like the rise and the run. So this one, we go up 1, 2, 3, 4. And then it goes over 1, 2, 3, 4, 5, 6, 7. So for our next dot, we need to go up 4, 1, 2, 3, 4. Turn the corner here and go down 7, 1, 2, 3, 4, 5, 6, 7. So our next dot is right there. For our next dot, again, we're going to go 1, 2, 3, 4. Turn the corner, go 7, 1, 2, 3, 4, 5, 6, 7. Last dot is right there. And now we've made a square. From there, we can make the square that goes on the outside and touches corners, vertices, and solve it as we would just like the other one. So the big square, we know it to be 7 plus 4, which is 11. So this side's 11, this side's 11. So we got 11 times 11 is going to give us 121. That's the big square. So this whole thing. And now let's look at minusing these smaller triangles. Okay, so remember we can find the area of these triangles by doing the base times the height. So we already figured that out. 4 times 7 is the base times the height divided by 2. 4 times 7 is 28 divided by 2. 28 divided by 2 is 14. Okay, wonderful. So now we found that each of these right here covers 14 squares. There's 4 of them, right? So we got to times that by 4, which is going to give us, let me do my calculator, 14 times 4, 56. So now let's go, I'm going to write it down. Big square minus triangles. Okay, so that's 121 minus 56. I use my calculator. 121 minus 56 equals 65. So that's the area of the square, equals area. And this is asking us for the length of the line segment. So we need to remember our relationship between a square and the side length. We need to find the square root of 65 to get that side length. So I know this is going to be a decimal. I know 65 is not one of our perfect squares. So let's press square root button. 8.06. 8.06. Let's call it units. And there you go. So that's how you do those ones. If it's just a line, you got to make the box first and then solve as we did up here. Okay, thank you so much.